Hello, it's Andy here, and welcome back to my walkthrough of the 2019 Sans Holiday hack. In objective number 7, we are required to gain access to the steam tunnels running throughout Elf University. As always, we'll take a quick detour to help an elf with a terminal challenge, but in order to reach Minty, we'll first need to get past a keypad lock. Tangle Coalbox tells us the code is a prime number, that one digit is repeated once, and that we should be able to make out the digits by looking at the lock itself. Sure enough, it appears as if the numbers 1, 3 and 7 are frequently pushed as they're starting to wear down. If one of these numbers is repeated, we can start by assuming that the code is 4 digits long. A quick Google online can give us the list of all 4-digit primes, all 1061 of them. Some Excel magic can help shorten this list. This formula uses the substitute function to take the prime number and replace all occurrences of a 1 with nothing. It then uses len to tell us the new length, and subtracts this from 4, the original length of the prime. The end result is the number of times that the number 1 appears in this prime. We can then duplicate the formula to tell us the same for 3 and 7. As we're only interested in primes which have a 1, 3 and 7, we can use an AND statement to check if a given prime contains at least one of each. Finally, we need to check for a recurring digit. The easiest way to do that here is to simply sum up all the quantity of changed digits across columns B, C and D, and so long as this adds up to 4, we know that all 4 digits are either a 1, 3 or a 7. With a quick bit of filtering, we're left with just 5 possible options, easy enough to try manually by hand. The last code, 7331, opens the door and gives us access to the student dorm. Inside we find Minty Candy Cane, who's trying to complete a computer game, and we'll get some clues for the main objective if we can help. The first thing that jumps out in the game is the URL, which contains many variables which can be changed. There seems to be some limits. Trying to increase our money balance too high results in an error. Giving ourselves lots of money is a good start, and we can then buy lots of reindeer to make good progress. On the next screen, we get the option to move forwards in the game, and we can see the distance remaining reduce. We're moving forwards, and giving ourselves lots of free money will make the game a lot easier, but it will still take a while. However, we can override the distance parameter to leap forwards and finish the game in just one more move. But that was on easy. What about medium and hard modes? In medium difficulty mode, none of the parameters are visible in the URL bar, but we can use the browser developer tools to spot that they're still being passed from client to server as a POST request rather than a GET request. Further examination of the page source exposes hidden input fields where all these details are stored, and it's again trivial to update the distance to leap ahead and beat the game in a couple of turns. Hard difficulty looks very similar. The game state is being passed as post data and stored as hidden input fields. But trying the same trick as before results in an error about a bad hash, and the game kicks us out. A closer look at the hidden input parameters reveals a hash value that's being passed along with the rest of the game state data. Given its length, this is probably an MD5 hash of the game state variables. But not every value seems to be protected by this hash. Changing the values associated with each in-game character, such as their health, is still possible. So what if we just concatenate the rest of the variables together and calculate the MD5 hash? No, that doesn't match. But these variables could be concatenated in any one of many different orders. We could write a script to test each programmatically, but before spending time on that, let's quickly check if the system is just arithmetically adding them together and producing the hash based off the result. And yes, sure enough, 1626 is the sum of all the non-character game state variables, and the MD5 hash matches that from the page source. So if we want to leap forward by 7,900 distance units, we just need to add 7,900 to 1,626, which gives us 9,526, and calculate the hash of that. In just a few more turns, we've managed to beat the game on hard. Trying the arithmetic sum of the game state variables sounds like a bit of a leap of faith, but actually there's a little hint hiding in one of the KringleCon talks to that effect. Okay, enough playing games. Time for a follow-up chat with Minty, who mentions a key cutter in their room and someone wandering around with a key. If we head to their dorm room, we find both the key cutter and a guy just leaving the room. It looked like he had a key on his belt, but it's quite hard to make out. But we can use our browser's developer tools to examine the assets which make up KringleCon. In amongst all the images, we eventually find Krampus.png, which seems to be just about big enough to make out the shape of the key, and therefore sufficient to make our own copy of the key. Having watched Deviantolum's KringleCon talk about creating keys from photos, we can see the key shape looks like a Schlanger-type key. He helpfully provides a set of excellent templates on his GitHub repo, so we can grab the relevant one and start manipulating it and the picture of Krampus in an image editor. Here I'm using GIMP. After a few minutes, it's possible to deduce with reasonable confidence that the pattern for this key, known as the bit encode, is 122520. We can then head to the cutter and create a key with this bit encode. The key is provided to us as a PNG, and then head back up to use it to open the door. The dark, winding corridor leads us down into the steam tunnels, where we find Krampus Holyfeld. He confesses to taking Santa's turtle doves, but apparently only borrowed them to fetch some scraps of paper that had been carelessly left by the fireplace and were posing a fire hazard. It sounds like Krampus has some secrets to share, perhaps about the cyber attacks on Elf University. To earn his trust, he asks for our help in winning the Frito Slay contest. That's objective number 8, which we'll tackle in the next episode. I'll see you there.